Hello, my data farm. Welcome. It's Henry, your favorite data engineer. In today's video, we're going to look at how to implement a where statement plus in, right? You combine where statement with in condition, right? In SQL, PySpark, and SparkSQL. This is very important because you want to be efficient in finding if a list of values or a list of numbers or a list of items are found in any of your database or in any column of your database, right? And to do that, it's very efficient for you to use the where plus the in statement, right? So this will help you be efficient and effective in finding these values and helping you to filter out and take out make sure that your values that you're looking for are in there or not, right? That is why you need the where and the in statement. It is very fast, efficient, and effective when you are using it for data filtering, data analysis, and transformation of your data as well. So come with me, let's take a look at how to implement this in SparkSQL, SQL, and PySpark, right? All right, welcome again. So let's continue and look at how to implement the where in clause in SQL. To begin with, let's take a look at our data sets, the underlying data that will be used for this tutorial today. To do that, you need to go to your catalog, then you look for samples. We're still going to make use of the healthcare data as well. So you come to the healthcare, then let's take a look at the columns. We're in the overview. The columns that we have here is pretty much just as what we had, right? HV ID, claim ID, and other things, date service. All right, quite a number of columns. Let's go to the next. Okay. All right. Let's take a look at the sample data. We need to start the serverless cluster. Right. Okay, so we wait for it to begin. It's running. Okay. Now, as stated, we are going to make use of the where in clause, right? This will help us filter data before the select is even applied on it. This makes your query faster. You are able to achieve results even easier or faster as you want it, right? So we can take a look at this is how the data looks like. Okay, we have a number of columns in here. Most of them are null, but for this scenario we are going to focus our where clause implementation on the HV ID column. The HV ID column is where we're going to base our where in clause, right? To filter out and then take and get the specific fields or the specific values that we want to see, the HV ID, specific HV IDs that we want to see in the table, right? So let's start with SQL. As I said, let's take a look at how many unique HV IDs do we have in this table, right? So let's go to a new and then go to your queries SQL editor. In your SQL editor, we create new query, right? And then we name this SQL underscore where, this way, right? And we check, let's check if the serverless is running. Yeah, I think it started, right? It's running, so we selected. So let's take a look at the full table as we already, and we know in SQL, to begin in the SQL world, the engine understands how your engine executes code is different from how you type it. Normally most SQL programmers or most data engineers, data analysts and all that, they start from select. But with the understanding that you have from my channel, where I explained how SQL engine executes the code or SQL processes, with that understanding, it would help you know that most often that is not how the engine is executed. And to get a full understanding to how SQL engines execute query compared to how you type your query, I have a video on my channel which you could check out, which will help you understand how to be able to know the how execution process of SQL engine. This is important because it will help you improve your queries, know where errors are done, and make your queries faster. So with that knowledge, if you don't know it, you can check my channel. I have that video in there. It would be of great help to you. We know SQL begins from the where, the engine. So where you go to the table, you pick the table, and we know Databricks have three namespace of naming tables. You begin from the catalog name, the schema, and the table name. That is how it's done. The catalog, the schema, and the table name. All right. So we want to know how many. Let's take a look at the full table of this, right? So select, and in SQL to see the full table, no filtering, nothing, you just do the star. So let's run this and see what we can see. This should be equal to the sample data that we took a look at, but in this case you have 4 more rows to view, right? Yeah. And what we want to see is, to begin, before applying our where clause, we want to see the unique HV IDs in the HV ID column, because you can see they are repeating, right? It's repeating because there are numerous transactions that have happened, right? Claims that have happened in this table. So we just want to see how many distinct HV IDs are in this table. Then we can apply based on that. We can select which specific HV IDs we want to see, right? So to do that, we just do distinct, then column name HV ID this way. Run it, then it gives you this. So this is the distinct number of HV IDs there are in this column. There are easier ways of ordering this so that you know from the lowest to the highest, right? In Databricks, it gives you some toggle in here, over here. You see how it shows. You can click it and it gives you ordering from descending order, right? Then this way, descending order is this is unsorted, this is ascending order, ascending order. As you can see, the name pops up from there, but we need it unsorted, so just as the original as it was, right? So great. So now we know there are so many distinct IDs in this HV ID column. Now this is where it gets interesting, right? This is where it gets interesting. Now we want to filter out and say we only need, let's say we are looking for specific HV IDs, all the transactions that have happened to some 3 specific HV IDs. Would you want to be doing it one after the other? That is, you have HV IDs. Let's assume you have, per our scenarios, we want HV IDs that are 993, 996, and 989. So we want to see these HV IDs. Are we going to write code for each one of them? That's going to be difficult. That's going to consume a lot of time. So what we are going to do is, this is where the where clause comes in. This is where the where clause comes in. So we want to see the full table, yes, which is star, where ideally if you want to do it one by one, or it will take a lot of time, you have so many IDs. These are just 3. You can have IDs where they are so much that you can't type all of them at once. But if you want to follow that order, it means you're going to do something like the HV ID where HVID equal 993, right? You run it. Great. It worked, right? It gave you all HVIDs that are 993. And how does SQL execute this? We already know that SQL engine first runs the table, gets the table. It will get the table, and then before it even does the select, it would grab the table, look within this table, the HVID column, which ones are 993, right? Which IDs are equal to 993, and then it filters that out before executing the full column and bringing you the data this way. That is how the SQL engine executes its code, right? Now, this ideally, you would also, if you want to do it the long way, which is boring, you also do all HVID equal 996. You would also get the data for you, right? If we look through, we should see 996. 996 this way. You can see 996 came in. I'm doing it in descending order. 996 or HVID equal 9. What we have here 989, right? This would also get it for you. This would also get it for you 989, as you can see, and would also get the 996. Would also get a 996 for you. 996, 993, and 989. It's all in, right? But putting it this way makes your query longer and not that efficient. We always want to write a shorter query which is quicker to execute, easy to understand. This is where the in clause comes in, works here. It's going to tell SQL that if you find any of these IDs within, or if you look in this column and you find an ID that is in any of these files or any of these numbers, pull all those ones for me. So this is how to do it. In where HVID in, right? These are numbers, so there's no need to include quotation marks. So 993, 996, 989. This is it. This is how you write the in clause. So you are telling SQL that go to this column. If you find IDs that are equal to or that can be found in any of this, or that is equal to any of this, bring all those IDs from. So if you run it, we still get our data, which is 993. You can see 989, 996, right? So this is how to implement the where in clause in SQL, right? This is pretty easy, right? The reason why this is important is because it makes your query shorter, much more understandable, flexible, and you are able to do more extensive analysis, or as a data engineer, you are able to write much more better queries for your pipelines and your flow, right? This is for SQL. Let's move right into how to do the same thing in PySpark. So in PySpark, we know we need a notebook. So let's open a notebook, right? Notebook, and name this PySpark where this way. Okay, nice. Then what we can do what we can do is to you can import the models, right, from PySpark .sql functions import star. If you don't know the specific models or the specific functions to import yet, I always advise to import star. So you import everything that is needed, right? Every function that is needed. So when you are using it, you don't have bugs, right? Your code doesn't break, and then you start to think, oh, why did this break? Why did that break? Because you made use of a function that you never imported or you forgot to import. That is the reason why I like to always use the star. So in that case, even if I forget and I make use of the function within my code, it is still imported, right, regardless, and I don't need to specifically import it. The moment I start doing import like something like this, then that means I'm importing specific things that I need for this particular notebook. But in this case, I just want to import star so that in the event I make use of anything, any of the functions, I am safe, right? I don't have a problem with that. So the first thing we know we need to do is to create a data frame, right? We need to create a data frame. So let's say claims equal Spark dot, we are reading from a table, right? Read dot table bracket open. This is the table. So we've created a data frame this way. So this data frame belongs to everything, right? You can choose to run it. Then we see how it looks, right? Then we see how it looks. Whilst that is all great, we can come to a new cell. So cell 1, this cell 1, cell 2. Or some people say line 1, line 2, but actually cell 1, cell 2, right? So this is still loading. Okay, the data frame is created, so you can see this the full column that we have in the data. So you can see it, and you can see it's a data frame that is created. Nice. We can choose to take a look at the data just as we do, right? So you can just see data frame. You can just say display claim, display claims. So this is already a data frame. You can display the claim, and then you take a look at what it's producing, and that should be equal to the original table that we took a look at, right? We did in SQL, where we just took a look at the full table and had an understanding of what we want to do. This is pretty much the same way to achieve that, right? But this PySpark, it's a framework or model in Python. So this is what it is. Great. So we have this. All right. Now let's then create in cell 3. Let's now implement what we spoke about. We can also see this is the same data that we worked with. So we are also going to implement the filtering on this to just extract HV IDs that are, as we said, 993, 996, and 989, right? Data HV IDs that are 993, 969, and 989. So to do that, let's create a new data frame as well. So claims, let's call df equal, the previous data frame is claims dot select, right? You apply a select on that data frame because you are going to select a portion of it, right? Or we want to select the full thing. Select, then we do just as we did in SQL. PySpark also has star. So to do that, we open quotations and then star this way. So this gives us the full table, every data within the table as well, and brings that to us. Now with this, we are now going to apply our where in clause, right? So it says where bracket open, and the column that we are looking at is HV ID, right? So claims dot HV ID, right? Dot in PySpark in where within is in this way, and then you open your bracket. That is how it works in PySpark. The in means to get the in, it's not a standalone in. You do it is in, right? Is in. So where HVID dot is in, right? Now the first value is 993, 996, 989, right? This is what we have. We can display this because we've created a data frame. Display claims underscore df. We run this and then we wait for the results. Great, super, it worked. So we can see we have 989, 996, and 993. So this is how to implement the where in, and it's where is in PySpark. This is how to do it. So you have been able to implement this. Ideally, if you didn't want to do this, you also implement or where, just as we saw in the SQL format, right? But with PySpark, and which is a model, a framework and model in Python, you use is in, right? Is in. Take note of that. Because these are numbers, you don't need to put it in quotation marks like this, right? You can just leave them as it is, right? So this works, and that is it for PySpark. That's how you can implement the where in or where is in, which is PySpark specific. Where in is SQL specific, right? Now let's go to SparkSQL. And as I've always been saying, once you know SQL, you'll be able to easily implement SparkSQL as well, because it is just a lift over to from SQL into the Spark framework, where you'll be able to use the Spark engine, or you leverage the Spark engine or the Spark model to run the SQL for you, right? So it is just a lift over, right? You just lift it and move it to Spark SQL. And let's do that. You also need a notebook because you are leveraging the Spark engine. So let's name it Spark SQL underscore where. Great. So with this also, you need to import the models, right? So from PySpark.SQL functions, import star, and we already know why that should be the case, right? Now let's create a data frame. Claim equal spark dot read dot spark dot SQL, sorry, and then you open three inverted commas this way, enter. So within it, that's where you write your Spark, your SQL code, right? The same code we wrote here is going to be the same code we'll bring in here. But note, always make sure that you indent your codes properly. Indentation simply means the arrangement. You indent it, what belongs to which, this belongs to that, right? So select, and then we say from this table, right? Select star. Select star. We said where HV ID in, right? In, just as SQL, in 993, 996, 989. And when you run this will create what? From what we've been studying, we know that this will create a data frame name claims. So let's run this. Whilst this cell is running, now you can display claims and see the data for yourself. So this will produce the result. Yes, so this gives you the result and filters out numbers that we specified within the where 989, 996, 993, right? So great. This is how to implement where in clause in SQL, PySpark, and SparkSQL. I hope you learned something. It's been pretty easy. It's not really anything crazy. It's very easy for you to follow and implement and learn this, right? And thanks for joining me. We've been able to implement where in clause in SQL, PySpark, and SparkSQL. Thanks for joining me today. Share, like, comment, and subscribe to my channel, because I'm coming up with some practical video which is project on, hands-on. It's going to be a long and interesting video, and you can add it to your portfolio as a beginner to understand the concepts in data engineering especially. Bye bye. So see you in my next video. Bye bye.